I'm talking about the sampling. Okay, so this we have previously discussed actually. These things we have previously discussed. Okay, so if you have a signal, okay, if you have a signal, you can send that signal through a switch. The switch can be a transistor or something. Then you can get the sample of these signals. Okay, for example, if you turn on this switch, you can get the sample. Let's say that from here. So that is this sample. Then you have off the switch again. So there is no any voltage or current. Okay, so again you on the switch. Then again you can get a sample. Okay, again you off, again you on. Likewise, you can get samples of this signal like this. Okay, and you can see that. So this is the first on time of the switch. Let's say that it is T1, and this is the second on time of the switch. This is 2, 2. Okay, so T2 and T1 is the duration, no? Duration between the sampling. Okay, between the sampling, between the sample. Okay, this T2 and T1. Okay, so if this T2 and T1, okay, if you take all the sample in the same time, if you take all the sample at the same time, same duration. Okay, like this. Okay, so this duration is same, this duration also same, this duration also same to this one. Okay, so this all sample durations are same. Okay, so you can assume. Okay, so you take the samples in a constant duration. Okay, so let's if that duration is t, if that sample duration is t, okay, and if you take 1 by t, that is the sample frequency. Okay, that is the sample frequency. Okay, so this is the time between two samples. Okay, so now we when we are representing these signals, we are not using the time. Okay, but we are using the sample number. Okay, then we are using n. Okay, so we take this sample as the first sample, this is second sample, this is third sample, and this is fourth sample, this is fifth sample, like this. Okay, so you have, this is the first sample. Okay, and this is the second sample, and this is the third sample, this is the fourth sample, this is the fifth sample, this is the sixth sample, seventh sample, eighth sample, nine samples, like this. Okay, so this will be 1, 2, and this sample will be 3, this sample will be 4, this is fifth sample, this is 6, this is 7, this is 8, this is 9. Okay, so if you want to find the time, okay, let's say that you want to find the time of this sample. Okay, so what is the time of this sample? If you, let's say that if you want to find the first sample, okay, so now you are on the switch within t duration, no? Okay, so we call this sample time, the time that you are taking the sample, time that you are taking the sample, that you are taking the sample. Okay, මේ time එක කියන්නේ ඔකට sample එකක් ගන්න වෙලාව. Okay, so now you are getting the first sample at t time, this second sample also at t time, the third also at t time, the fourth also at t time, like this. Okay, so this is the first sample duration, and this is the first sample. Okay, so if you want to find the t corresponding t here, t1 is equal to, the sample is 1 into t, no? So this is the t. Okay, if you want to find the t2 sample time, t2 is, the sample value is 2, and it is multiplied by t. Okay, now if you want to find the fourth sample, time. What is the value? Let's say that it is T4. Now you want to find the fourth sample value, time value. Okay, not the sample. Now the sample number is 4. Okay, now you want to find the time, corresponding time to this sample. So what is the value? Can you tell? What is the value? So this is the first sample. Okay. And this is the second sample. This is the third sample. This is fourth sample. This is fifth sample, so on. Okay. Yeah. Very good. Okay. So it is, yeah. Very good. Okay. So actually it is 4 by T. No? Yes, very good. Now let's say that you need to find the nth sample time. Nth sample time. Let's say that it is Tn. What is the value? The sample number is n. So what is the value? Yes, very good. That should be NT. That should be NT. Okay. So the corresponding time, sample time, we can represent as the sample number into sample time. Okay. So the T, so you can see that this N, okay, let's say normally this is this is normally referring from simple length. Okay. So T is equal to N simple length by T. So this N is the sample number, 1, 2, 3, 4, like that. Okay. So this T is the sampling duration. Okay. And if you take 1 by T, that is the sampling frequency. The frequency, how many samples you are getting for 1 second. That is the sample frequency, no? How many samples? Sample frequency means how many samples or number of samples you are getting for 1 second. That is the sampling frequency. So you can get one sample you get from T time, okay, from T duration. So for 1 second, you are getting 1 by T sample, okay. So this is the sampling frequency, okay. So I think now you can understand what is N, what is sample time, and what is sample frequency. This is the number of sample number, not the number of sample, okay. This is the sample number. So it can be minus also, okay. It can be minus infinity to plus infinity, okay. And this T is the sampling time, the time you are getting the sample, time duration you are getting the sample, and this is sampling frequency. Okay, sampling frequency. That is how many samples you are getting for 1 second. Okay, so this F is equal to 1 by T, and corresponding time for any sample is given using this equation. So you better remember these two equations also. Okay. So I think you can understand, no? This. Is there any problem? If any problem, please ask me, okay? Then I can explain it again. ඔකට මොනවා හරි ප්‍රශ්නයක් තියෙනවා නම් අහන්න නිකන් තේරෙන්නේ නැහැ වගේ තරක් තියෙනවා නම් අහන්න හරි බය වෙන්න එපා මේ නිකන් අර හිතන්න එහෙම එපා ඒවා නිකන් මොඩ ප්‍රශ්නයක් වෙයි එහෙම හිතන්න එපා මොනවා හරි තේරෙන්නේ නැති දෙයක් තියෙනවා නම් ඒක අහන්න හරි මොකද ඔය කට්ටියට මේක ඔළුවට යන්නේ එක එක විදිහට. සමහරට හරි concept එක ඔය කට්ටියගේ ඔළුවට යන්නේ නැහැ එකපාරටම. හරි. එතකොට මේ ප්‍රශ්න අහලා තමයි ඔය කට්ටියට හරි concept එක ඔළුවට දාගන්න වෙන්නේ. හරි ඒකින්ද බය නැතුව ප්‍රශ්න අහන්නේ කියන්නේ. ඔය කට්ටිය වැරදි ප්‍රශ්නයක් අහුවොත් ඒකේ තේරුම concept එක ඔය කට්ටියගේ ඔළුවට ගිහිල්ලා නැහැ කියන එක. එතකොට ඒක සමහරට මම උගන්වපු විදිහේ වැරද්දක් වෙන්නත් පුළුවන්. හරි. ඒක ඔය කට්ටියගේම වැරද්දක් නොවෙන්නත් පුළුවන්. සමහරට මම උගන්වන විදිහ මේ මොකක් හරි ප්‍රශ්නයක් ගින්ද ඒ concept එක ඔය කට්ටියගේ ඔළුවට යන්නේ නැති වෙන්න පුළුවන්. හරි ඒකින්ද මේ හොඳම වැඩේ තමයි ඔය කට්ටියට මොනවා හරි දෙයක් තේරෙන්නේ නැත්නම් බය නැතුව ඒක අහන්න. මේක මොකද්ද කියලා මේ මෙතන හරියට තේරුණා ඒකේ මොකද්ද කියන්නේ කියන එක. මොකද ඒක එහෙම දෙයක් ආවොත් අපි ඒකට උත්තර දෙන්න ඕන. හරි. සමහරට මම එක්ස්ප්ලেইন කරන එකේ ප්‍රශ්න හින්දා ඔය කට්ටියට ඕක තේරෙන්නේ නැති වෙන්න පුළුවන්. හරි. ඒ තේරෙන්නේ නැති එක ඔය කට්ටියගේ ප්‍රශ්නයක් නෙවෙයි වෙන්න පුළුවන්. right. ඒකින්ද බය නැතුව ප්‍රශ්න අහන්න. හරි okay. Now let's come to our subject, okay, our topic, okay. Now we are going to learn basic discrete time signal. Basic discrete time signal. So I have told you that we are going to learn three things, three function, that is unit step function, unit impulse function, then sinusoidal function. Okay. So these sinusoidal sequence, normally these are called sequences. Okay. Discrete time signals we can also refer as sequence because we have some sequence of values. Okay. So we can call them as a sequence. Okay. Okay. Now so we have to learn these three type of basic discrete time signal. Okay, give me a moment. Okay, so okay, first we take unit step sequence. Okay, the unit step sequence. Okay, so I think you know the unit so continuous time unit step signal. You have already know it. Okay, so this is T. This is the unit step continuous time unit step signal. Okay, then it comes to discrete. That means you have to discretize this. That means you have to sample this. You have to send this signal through a switch. Okay, like we have done here. Okay, like we have done here. Okay, so now you are, let's say that you are going to switch this on and off in t time duration. Okay, then you will get let's say that you are starting from 0. Okay, you are starting from 0. So 0 you are getting the first sample. Okay, actually we refer this it as 0th sample. Okay, if any sample is here, it is the 0th sample. Okay, okay, now you have this sample. Okay, then after t time you will have another sample. Then again after t time you will have another sample. Again after t time you will have another sample. After t time you will have another sample like this. So this is okay. So this is 1. Okay, and this sample also 1. The sample value also 1. If this is the voltage signal, this sample value will be 1 voltage. Okay, so it is just like this. Okay, okay, so you have a power supply here. Okay, මේක තේරුම් ගන්න බලන්න මේ විදිහට. You have a power supply here. Now you have set this power, let's say that to 1 volt. Okay, now you have a switch. like this, okay? So you have a minus probe and plus probe, okay? You have set the power supply voltage into 1 volt, okay? Now let's say that you have, okay, let's say that uh, you have connected this to a load, okay? Connected this to a load, okay? Let's say that instead of load, you are connected this to a oscilloscope, okay? DSO, oscilloscope. Now, what you are doing, you are turning on this switch, okay? Then you have a voltage value. At 0 point, you have turned on this value. Turn on a switch, okay? Then you have 1 volt here, okay? Then instantly you switch it off, okay? But practically you can't do it, okay? Practically to switch off the switch, you will have some time, okay? Practically මේක කරන්න යනකොට මෙතන පොඩි time duration එකක් තියෙනවා. But now assume that you have instantly, very quickly, or without 0 time, you turn off the switch, okay? Turn on, then suddenly turn off, okay? So you have 1 volt here, okay? If you have a bulb here, the bulb will light up for a moment, okay? Then again off, then this light is turned off, okay? So there is no value in DSO. Again you turn on this, then you have then another value. After this time, again you on the switch, okay? So you have this sample again. You have turned on the site after another t second. You have this sample, okay? Likewise, you will have the samples, no? Okay? So normally we referred this 0 section sample as 0 sample. This is first sample. This is second sample. This is third sample, fourth sample, fifth sample, so on. Okay? Okay. So normally, instead of time, we are taking this n, okay, number of sample. But this n is also related with the time t and t, like this. Okay. So this n is also time value, but normally we are not referring the time. We are just taking the samples, sample number. Okay. So this is the unit step sequence. So you have one's value. Okay. So if you can represent the unit step function like this also. You have some one's value up to infinity. Okay. So it is sequence of 1, no? It is a sequence of 1. Okay. ඒක තියෙන්නේ 1 ටිකක් නේ 1 sequence එකක් 1 කියලා 1 වල sequence එකක් තියෙනවා. So that is why we called it sequence, okay? Unit step sequence. So you can write it like this also, okay? And also you can write it like this. Un is equal to 1 when n is greater than or equal to 0. From this 0, if this n is greater than 0, that means 0, 1, 2, 3, 4, 5, 6, okay? Un is 1 and un is 0 if the n is less than 0. Okay. So this is the unit step sequence. Okay, this is the discrete time unit step sequence. Okay. Okay. Now let's take the unit impulse. What is unit impulse actually? Unit impulse means, okay, 1 sample. This is 1 sample. Okay. Actually, the impulse are not practical. Okay. This is not practical. This is not practical. Because for an impulse, okay, the time duration for this impulse should be 0. Okay. The time duration of an impulse, time duration of an impulse is 0. This is, we can't, if our electronics is very high performance, if we have very speed electronics, we can't make this time 0, no? So for a switch on and switch off, definitely it will take very few seconds, maybe nanosecond, maybe picosecond. Okay, so it can be very tiny duration. Okay, but still there is a duration. Okay, so we should be so it is not practical, no? The time, if the 0 time durations, if we take the something with the 0 time duration, so it is not impossible, it is not practical. Okay, so basically this unit impulse function is not practical, but this is not complex actually. Discrete time unit pulse. Okay, the continuous time impulse is not practical at all. Okay, not practical. Continuous time impulse is not practical, and also it is mathematically complex. This is mathematically complex. Okay, but unit impulse unit impulse, discrete time unit impulse is also not practical. It is impractical, but it is not mathematically complex. Okay, it is very mathematically, it is easy because the continuous time we put the arrow. That means the area should be here. We are not talking about the area. The value is what. Okay, so if you represent the unit impulse, okay, unit impulse. So normally preferred using delta n. Okay, using delta n. So it is like this. This is 0. Okay, so this is the unit impulse. Okay, and the value of this is 1. Okay, but here the for the continuous time, this 1 is not a value, it is the area. So that is why we have to take the integration always. Okay, but here we no need to have an integration. Okay, this is simple one, the value is 1. Okay, so this is a unit impulse. Okay, for example, if you take a very tiny pulse, very narrow pulse, very narrow 1 volt pulse. Okay, let's say that this time duration is very small. Okay, it is 0.0000 something nanosecond. Okay, very small. Okay, practically we can't get. Okay, I think practically we can make around maybe 40 gigabit per second. Okay, so 40 gigabits per second. So 1 bit is around 1 by 40. I think this kind of pulse we can generate, this kind of duration pulse. Okay, with this electronics. Okay, but let's say that somehow we have generate a very tiny pulse. Okay, so it is very much similar to a unit impulse. Okay, it is not the same, but it is very much similar because this time duration is 0, very near to 0, not completely 0, very near to 0. Okay, so this is the unit impulse signal. Okay, and normally using MATLAB, we can generate unit impulse signal, discrete time unit impulse signal. But in MATLAB also, we can't generate continuous time unit impulse signal also. Okay, but in MATLAB, we can generate discrete time unit impulse because the value is here 1. Okay, okay. Now this unit impulse, okay, actually it is also we can represent as a sequence, but there is no sequence of ones, only one is there. Okay, but it is also referred as a sequence. Okay, so you can represent this delta n, the unit impulse sequence. This is the unit impulse sequence. Okay, this is the unit impulse sequence. You can represent it as like this 1 and 0. What is this value? And what is this value? Can you tell what is the value? What is the range? At what point the value should be 1? At what point this value should be 1? Yes. Yes, very good. Now what about you? At what point this should be 1? Yeah, this is when the n is equal to 0, this should be 1 because the 1 is that n is equal to 0, no? The 0th value is the 1. Okay, 0th value is the 1. Okay, so n is when the n is equal to 0, the delta n value should be 1. Okay, otherwise it will be 0. If n not equal to 0 or otherwise, this value will be 0. Okay, so this is the mathematical representation of the unit impulse signal. Okay, now can you draw this signal? If I ask you to draw delta n minus 3, okay, so what is this? How we can draw this? Okay, so this is time shifting, no? It is shifting to this way. Okay, so now it is in n domain, okay, not the time n, okay. So now you have to plot delta n minus 3, okay. That means it is shifting 3 samples, no? It shifting 3 samples from this side. If this is a continuous time, if we means t minus t, this t is the time, okay. It is the time second, t second, it is shifting to this way. But here it is 3 samples. You should remember that this 3 samples means they are also corresponding time, no? That is 3t. Okay. So this is the corresponding time actually. Okay. So you can write it like this. Okay. So this is 0, this is 1, this is 2, this is 3, like this. Okay. And if I ask you to draw to delta n minus 4 or something, you can easily draw it. Okay. So it is shifting to this way by 3 samples. Okay. So this is 0, this is first sample, second sample, third sample, and fourth sample. It is there. Okay. So this will be delta n minus 4. Okay. So if I ask you to write delta n minus n, okay. So you have to shift n number of samples, no? So it will be anywhere here. Okay. And if this is plus, what that it means? It is shifting to this way. Okay. So if I ask you to write n delta n plus 3, okay. So this is 0, this is minus 1, minus 2, minus 3. Okay, if I ask you to write n plus 3, so it will be here. Okay. Okay. Now, if I ask you to write, okay, if I ask you to write un, okay, as a sum of delta n minus n, can you do this? Can you write this? you need to write the unit step sequence. This is unit step sequence using the unit impulse sequence. So can you do it? Try to do this. Take 5 minutes and try to do this. පොඩ්ඩක් කල්පනා කරලා බලන්න කොහොමද ඒක කරන්නේ කියලා.
Excuse me, sir. We can't hear.
Yeah. Thank you. Listen, okay. I'm sorry. Okay, I will. Now, I will do this one. Okay, I will do this one. But before doing that one, I'm just asking you this question. Okay. So delta n plus or minus n. This is the shifted unit impulse signal. Okay, this is the shifted unit impulse signal sequence or signal. Okay, okay. Now delta n plus or minus n. If it is plus, it is shifting to this way. If it is minus, it can be shifting to this way. Okay, so if it is plus or minus n, okay, so for the shifted unit impulse, this is 1. This is equal to 1 when n is equal to what? මේක එක වෙන්නේ මොකේට සමාන වුණාමද? So here I have draw the shifted unit impulse. No, these are the shifted unit impulse. Okay, so this is n minus 4. So this is 0, 1, 2, 3, 4. Okay, so this is n plus 3. So it is 0, minus 1, minus 3, minus 2, minus 3. Okay, so this is n minus. Okay, n minus capital N. So it is after the nth, at the nth sample, capital N sample, you have an impulse. Okay, the value is 1 always. Okay, these values are 1. Okay, and so when n is equal to what, this is becoming 1. In මොකේට සමාන වෙනකොටද මේක 1 වෙන්නේ? Shifted unit impulse එක. Okay, no, no, no. If it is a unit impulse signal, n is equal to 0, no? The unit impulse signal is like this. It is at, this is 1 at 0. Okay, so delta n is equal to 1 when the n is equal to 0. But now I am talking about shifted unit impulse signal. Okay, for the shifted unit impulse signal at 0, it is 0, no? You can see that. This is the one shifted unit impulse signal, n minus 4. It is shifting by 4. Okay, so these are zeros. Okay, only the end point you have a value. Okay, so delta n plus or minus n, the shifted unit impulse sequence is equal to 1 when the simple n is equal to what? Yeah, I have drawn. So this is delta n minus 4. This is n plus 4, n plus 3. So you can see that the impulse is here. Others are 0. Okay. So for the unit impulse signal, what is this value should be? When it is 1, so you can see that if this is 4 minus 4, the value is 1 at 4th sample. If it is plus 3, the value is value is 1 in minus 3rd sample. Okay, so what is this value? No. Okay. 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 So this is delta n. Okay. This is delta n. Okay. Now delta, if I draw the delta n, okay, that is the unit impulse signal, unit impulse sequence. Okay. So when the n is 0, that means zeroth sample, you have an impulse. At the zeroth sample, you have an impulse 1. Okay. So this is the unit impulse sequence. This is the unit impulse sequence. Discrete time unit impulse. Okay. Now, let's say that you want to find, you want to draw delta n minus 1. Okay. So how you draw it? Your impulse is shifting to this way by 1. Okay. So it is minus 1. So your impulse is shifting to this way. Okay. So you can see that now it is not 0. At first sample, it will be 1. Okay. So this n is 1. Okay. Okay. I didn't get the correct answer. Okay. Okay. Now focus on this one. Okay. Now if I write delta n minus 1, it is like this, no? Because this unit impulse is shifting one sample from this direction. Okay. So it will be here. Okay. It will be here at the first sample. Okay. Now you want to write, let's say that you want to write delta n minus 5 or something. Okay. Now this impulse is shifting to 5 times, no? Okay. So here it is 1, 2, 3, 4, 5. At 5 sample, now this impulse is shifting from 5 samples to the 5 samples. Okay. So you have at 0 there is no sample now. It is shifting. Okay. It is shifted to 1, 2, 3, 4, 5. Up to this. Up to here. So this is delta n minus 1. This is delta n minus 5. Okay. Okay. So if I write delta n plus 5, okay, it is shifting to this way. Okay. Now you have previously it is at 0. It is at 0. Now this is shifting to this way. Okay. By 5 samples. Okay. Now you have minus 1, minus 2, minus 3, minus 5. So here now your impulse is here. This is 1. So this is delta n plus 1, n plus 5. Okay. This is delta n plus 5. Okay. So if it is minus, it is shifting to number of samples here in this direction, delayed side. And if it is plus, it is shifting to advanced side, time advanced side. Okay. Into this direction. Okay. Now consider delta n minus n. So now where is the impulse? It should be at the nth sample, no? Not the 0, 1, 2, 3. It should be at the nth sample. So this will be delta n minus capital N. Okay. And if is delta n plus n, where the impulse should be? It should be shifted to this direction. Okay. The minus side. Now it is 0, 1, 0, 2, 0, 3. Like this. It should be now at the minus nth location. No. So this will be delta n plus n. Correct. Okay. So now I am asking now when. So you can see that delta. So if I go to this one, delta n minus 5 is equal to 1 when n is equal to what? n මොන වෙලාවෙදී මෙහා එක වෙලා තියෙන්නේ? මෙතනදී n is equal to what? 5. Okay. When the n is equal to 5. Okay. Here, delta n plus 5 is equal to 1 when n is equal to which one? N plus 5 equal to 1 when n is equal to what? Is it 5? Yes, when the n is equal to minus 5, no? Okay. Now I am asking the question. Okay. Delta n simple n minus n is equal to 1 when n is equal to what? Here minus, it is shifting to this way. So what is the sample number? What is the sample number here? It is shifting to n, to this side. Yes, very good. It should be plus n. Okay. And here, if I write n plus capital N, where this is, if it is equal to 1, when the n is equal to what? Yes, it should be minus n. Okay, this should be minus n. Okay, so I have asked you that when delta n plus or minus capital N is equal to 1, when n is what? When it is plus, it is equal to minus. When it is minus, it is equal to plus at 10. Okay, so it should be minus and plus n. Okay, so you are writing, you have write plus and minus, no? So it is not correct. So here it is plus. If it is plus, it should be minus, and if it is minus, it should be plus. Okay, and otherwise it is 0. Okay, this is 0 otherwise. Okay, so this is how we mathematically represent the shifted unit impulse sequence. Okay. Now our question is how to represent the unit step sequence as a sum of shifted unit impulse sequence. Okay, so if I draw, okay, if I draw the unit step signal, okay, if I draw the unit step signal, okay, so when the n is equal to 0, n is equal to 1, n is equal to 2, 3, 4, up to infinity, up to plus infinity, this value will be ones, no? Okay, so you have like this. Okay, so this is the un. Okay, now if you write the delta n, you have one sample here. Okay, now if you write delta n minus 1, if you write delta n minus 1, delta n minus 1, so where is the sample now? Where is the impulse? It should be at plus 1, no? Okay, so now you have the impulse here. So if delta n minus 2, okay, so now the impulse should be at 2, no? At plus 2. Okay, so the impulse should be here. Okay, and if delta n minus 3, let's say that minus 10, so it should be at 10. Okay, like this. Okay, now what is the unit step signal? You can make this unit step signal by adding this shifted one, no? By adding this shifted one together. Okay, Okay. For example, you can make the unit step signal by adding. First you add delta n. Okay. So it is like this at 0. Okay. Now you add delta n minus 1. So now it is at 1. Okay. Now you add delta n minus 2. Now it is at 2. Now you add delta n minus 3. Now it is at 3. Now you add delta n minus 4. Now it is at 4. Okay. Likewise, if you add delta n minus 100 or something, so here you will have 100 at 100. Okay. Likewise, if you have add n minus infinity, you have the impulse at the infinity also, no? Okay. So this is the unit step signal, no? This is the unit step signal. You can write the unit step signal as a summation of shifted unit step signal, unit impulse signal. Is this clear? Make it clear now. Okay, so you know that unit impulse, unit step signal is a collection of impulse, no? There should be impulse as 0, 1, 2, 3, up to infinity, there should be the impulse, okay? So if you take the unit impulse signal, at 0, you have an impulse. If you have shifted unit impulse signal by 1, you have at 1. If you have a unit step signal by 2, you have 2. Likewise, you have a sequence of unit impulse, no? So you have a sequence of impulse. Okay. Then if you add them together, you can make this kind of sequence, no? Up to infinity. Okay. Is this clear? If it is not clear, please ask me, okay? Then I can explain it again. Is this clear? So now I ask you to write the unit step signal from as a unit impulse signal, as a sum of unit impulse sequence. Okay. So you can write it like this. Okay. Okay. Now, okay. Thank you. Okay. Okay. Now, actually, you can use the sum notation. Okay. You can use the sum notation. This notation to represent this addition. Okay. Represent this addition. So it is like this delta n delta n minus, let's say that capital N. Okay. So this n should be from 0 to plus infinity. Okay. And this is un. Okay. So you can write this like this. Okay. So that means n is equal 0 to infinity. Okay. So this n means this n. Okay. So the first one is n is equal to 0. So this n, capital N is 0 to equal to 0. So it is n minus 0. So you will have delta n. This sum notation means it is the plus. Okay. Now n is equal to 1. So you have n minus 1. Then when the n is equal to 2, it is equal to delta n minus 2. So on. Finally, when the n is equal to plus infinity, it will be delta n minus infinity. Okay. So you can use this notation. Okay. Is this clear? This is just a notation. Okay. So you have to familiar with this notation. Okay. You have to familiar with this notation. It is very important to your final examination. We will do some more example. Okay. So you will be familiar with that one. Okay. So, Please keep remember this thing. Okay. Fine. Now, let's say that we have a sequence. We have a sequence. Let's say that xn is 1, 4, 5, -6, 0, 2, 3. Okay. So this is the value, some value sequence. Okay. And let's say that, so these are the sample values. Okay. Let's say that this is the 0th sample. This is the 0th sample. Okay. So if I write like this means that 5 is the 0th sample. Okay. This is the 0th sample. Okay. Now, so if this is the 0th sample, these are plus samples and these are minus samples. Okay. So this will be +1 sample. This will be the second sample. This will be the third sample, and this will be the fourth sample. This will be the fifth sample. And this will be -1 sample, and this will be minus second sample. Okay. So like this. Okay. So this arrow always show the 0 sample. Okay. So you can represent a discrete signal like this as a sequence of number. So this is given. These values are the impulse value actually. Okay. So you can write this xn. You can write this xn like this. Okay. So at 0 it is 5. At 0 you have 5. Okay. At 1 you have at 1 you have -1. That means this direction. You have -6. Okay. So this is 5. This is -6. At 2 it will be 1. Okay. At 3 it is 0. At 4, okay. At 4 it is 2. At 4 it is 2. At 5 it will be 3. Like this. Okay. At -1 it will be 4. At -2 it will be 1. Okay. So this is the signal. This is the discrete time signal. Okay. And you can represent it as a sequence in this way. Okay. Is this clear? You have to familiar with this one also. It is very important. Okay. Is this clear? Or any undoubt point? I just draw the sequence. Okay. So I have the number of the value of the xn. Okay. And this is the 0th sample. And this side, the right-handed side samples are the plus sample. The left-hand side samples are minus samples. So you can write your sequence, your discrete time signal. You can draw your discrete time signal in this way. Is this clear? Make it clear. Yes, thank you. Okay. Okay. Now try to draw this. Okay. So do it as a homework. Okay. So we will stop here. Okay. Now try to draw this signal. Okay. That means this signal as a collection of shifted unit impulse signal. Okay. So try to represent this sequence. Okay. Try to represent the xn. Try to represent the xn as a collection of shifted unit impulse signal. This is n plus or minus. Okay. So try to do this. Okay. So I think you can do it. Okay. So try to do this. Okay. So at the next Tuesday, we will try to do this kind of questions. Okay. So try to go through this lecture and be familiar with this notation. Okay. So I will upload this lecture today. Okay. And please ask your friends to go through that one. Okay. So at the interaction session, we will do some practices. Okay. So you will be familiar with these things. Okay. So ask them to go through this lecture, come with idea. Okay. Then it is easy to continue. Okay. Okay. We will stop here. Thank you for your participation. Now then Tisuni. Okay. So we will stop.
Thank you very much, sir.
Okay.
Thank you, sir.
Okay. 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 I will leave. Okay. If you have any problem, you can ask. Okay. Problems තියෙනවා නම් අහන්න.